Well, hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin and today we are going to solve lab number 1 from web cache poisoning vulnerability. So in the previous lab we understand what this web cache poisoning is all about and how it could be exploited, what is the mechanism, okay, and what should be your approach if you find this vulnerability to exploit it. We approximately covered everything, the theoretical part, and today we are going to solve its lab number 1. One thing which I leave or which I left in the previous lab, that is parameter miner, and I will cover this parameter miner today because it will help you to detect the unkeyed headers. Okay, so we will see that in a minute, don't worry about that. And these are the labs. So this vulnerability arises because of two kind of flaws. First one is cache design flaw and the second one is cache implementation flaw. So we will start with the cache design flaw. So let's go. And in the cache design flaw, there is the first section where we will exploit the cross-site scripting via using web cache poisoning. But these labs required burp collaborator, so and that requires the professional version of burp suite. So I leave this section right now and I will jump to the second section, which is using web cache poisoning to exploit unsafe handling of resource import. So what does that means? Because you might have seen a lot of time that when you go for the directory enumeration of any web application or website, you find /resources directory most of the time. So what happened, a lot of websites are there, those dynamically import the resources from external sources or from external hosted JavaScript files. So in this case, if an attacker changes the value of the appropriate header to a domain that attacker controls, means the attacker control domain, at that instant it could be possible to get the malicious response and you can manipulate the request. So if the response contains this malicious URL in cached, the attacker's JavaScript file would be imported and executed in the browser session of any user whose request has a matching cache key. So everywhere, while we are going to solve all those left from web cache poisoning, everywhere you will use these terms like uncached key and cached keys. So I already explained it. If you did not watch that video, please go to the first video, which is web cache poisoning brief. Okay, so I'm directly going to the lab, which I already open here. So this is our lab and I'm going to read the description first. So web cache poisoning with an unkeyed header. Okay, so unkeyed means anything that is not used by cache to match the request, that is unkeyed. As simple as that. Now the agenda is this lab is vulnerable to web cache poisoning because it handles input from an unkeyed header in an unsafe way. An unsuspecting user regularly visit the site's homepage. To solve this lab, poison the cache with a response that execute alert document.cookie in the visitor's browser. So, okay, so first of all, you need to find out that unkeyed header, which unkeyed header that request support or that server can be process that unkeyed header, because there are a lot of non-standard HTTP headers. Many headers are there, but you need to find out which one can be processed by the server, and you can get the result of that header into the response. And then what you will do, you will try to get the malicious response, and then that malicious response will be saved in the cache, and any user come with the same request, the cache is going to send the same malicious response to all the users, malicious or poisoned response, right? Okay, so first thing first, the first thing I would like to show you how you can install that parameter miner, because in that way, by using parameter miner, you are going to get the unkeyed header. So for that, you first of all need to go to your extender, and inside extender, because I already installed it, so I can see here this Java parameter miner. But if you did not install that, you will not see anything here, so do not need to worry. Just go to the B app store, and inside B app store, on the right hand side, you will find a search bar. Here you can write param miner, and there you go, you have here parameter miner. Just install it, because I already installed, so I can reinstall, but here you will find install button, so just install that. And once you install it, here you will find parameter miner and its setting. Okay, and if you go to extensions, here you will see the parameter miner extension. Fine. So how you will use that parameter miner, I will come to that point once we try to mine the unkeyed header. So that's been said, let's come here, just start the browser. First of all, let's just consider that this is an unknown application and you don't know anything about the vulnerability exist in this application. Means you don't know whether this application is vulnerable for web cache poisoning or not. Okay, so what you will do, suppose you are started analyzing the behavior of the application, request and response. So you just turn on your burp suite on your browser, and you just try to hit the home button. Okay, and this request is completed. Go back to the burp suite, go to the proxy HTTP history, and this is the first request. I'm going to target actually and just put it add to scope, so I will not be disturbed by other requests, because Mozilla Firefox usually send and receive many requests. Okay, so this is the request. So request, if you see, the request is normal, there is nothing special. Just a moment, go to the display, and I would like to make it 16. Now that's feel better, and you can see, oh, the font size is still, so change the font size and make it, let's say 16:2. Okay, now proxy, yeah, and now the font size is changed. So now the request, if you see, the request is pretty much normal, but if you see the response here, so what I mentioned in the previous lab, that you will find like cache control. This is the first response header that indicates that the cache is used in between you and the server, and the maximum age of the cache is 30 seconds. And the time when I make this request, there is 0 seconds, and as you can see, X cache response header value is missed. Missed means this response is not coming to me from the cache. This response came to me directly from the server, not from the cache. But what happened if I send this request to the repeater? I go to the repeater and send this request again, because I while I was explaining this, 30 seconds has been passed, and then I make the request again. So again you see X cache is missed because this is not coming from the cache. So I send it, and this time you see we got hit. That means this response is coming from the cache, because once we make the first request, the copy of that response is saved in the cache. Okay, and when the next time I send the request, we get the hit. That means the response came to me from the cache, and the second time when I make the request, 21 seconds already passed. Now, so if I send the request again, this time I will get the miss here. The X cache value will be miss because 30 seconds has been passed. So see, that's the thing. So that confirms this is the first step, and that confirms that there is a cache in between me and the server. So this is the first thing. Now the second thing is we need to identify that how this cache is working, means what are the keyed cache and how this cache is identifying the request. So as I mentioned, mostly from these two lines, from the host header and the request parameter and the endpoint. So let's see, I'm going to change this endpoint, let's say ABCD, and send this request again. So now what you will see here, that because this endpoint is new, so maybe we will not get miss and the endpoint not found. Okay, and next time when I did that, you can see this endpoint is not a valid endpoint, but still the response is getting saved in the cache. So anyone from anywhere, if access this same endpoint, the response will be sent by the cache. Okay, fine. So this is one of the important point here I would like to mention. Whenever you are going to test for the web cache poisoning, because this is the production server, suppose that, and if you manipulate anything and the response goes wrong, so at that instant you already feed something in the cache, and that response is going to be served in the next time to all the users. So that is going to be the problem. So your testing should not be affect the end users. So keep that in mind. What we can do, this endpoint is invalid, we know that. So let's try as a parameter, not the endpoint or not the directory, as the parameter is equal to 123, and send this again. So now as you can see that this is again unique and not valid, and normal user will not come to this. This will be limited only to us, and we know this endpoint. But the thing is, application is responding to that. And if we go scroll down, view details, and everything is coming. So as you can see, this is the first time it's miss, second time once we hit, again miss, send again. So now the response is feeded in the cache, and we are getting the response from the cache. And so if I say copy URL, go back to the browser, and let's open new private window and paste it here, send that. Okay, now go to the proxy, and let's see, the response came. This is the last response. Let's see, refresh again. Yeah, this is the thing. Now it is missed because the time has passed. 30 seconds is very little time, and second time here we get hit, and it's only 7 seconds. Okay, this is the first thing. Now the thing is, we need to find out now the unkeyed header. Okay, go to the repeater, right click here, and here you will find extensions and parameter miner and guess parameter. Okay, or parameter miner. So there are different options like guess get parameter, cookie parameter, guess headers, guess everything. In the parameter miner you will find header poison, port denial of service, unkeyed parameter, fat get request, normalized parameter, a lot of things. So I would say guess headers, okay, and leave these as default. I will explain things if we need to change something, but you can read whatever terms are here, parameters are here. Fine, just make it okay and send the request again. And now as you can see, this is miss. Send the request again. Now go to the extender, come here, go to the output, and here what we see, let's see. Yeah, it's initialized. Now it's brute forcing from the line number 6, and in few seconds it is going to give us the unkeyed header. Go to the repeater again, send the request, and go to the extender. Okay, so we need to give it a time because it is going to match every header value. Okay, till then I can explain you what we are trying to do. Now the thing is, if you see the response here, you can see few things. The first thing here, you can see it's loading the resources in the response from somewhere. Okay, so this is, I think, the local directory, CSS, and this is a script type Java script, text JavaScript, and you can see this is the important part. Source is equal to this, and there is a file which is tracking.js. So that means it is also getting some JavaScripts from a JavaScript file named as tracking.js, but the URL, the source is this. So if we can manipulate this domain name and we put here any attacker control domain which we control, and we publish the tracking.js within the same directory structure, so we can save that response in the cache, and then the cache response will be served to all the user. Any user come with the same request will be served to all the user, but here instead of this domain, user will get the attacker control domain, and this tracking.js will load the JavaScript resources what attacker poisoned in the cache. So if there is any alert, or maybe attacker try to extract the cookies or credential or anything. Okay, so let's see, go back to the extender first, and now we get that. So as you can see, we found few unkeyed header. We are saying it unkeyed header because these are the headers not going to see by the cache to match the request. So the first one is X forwarded host, and the second one is origin HTTPS. So we will go with the first one, which is X forwarded host, and every header has its own functionality. So because we need to serve the host name here, so I think X forwarded for is going to be work for us. So let's take this X forwarded host, go to the repeater again, and what I'm going to do, I'm going to feed it here, X forwarded host, and the host, what is the host going to be? So come back here and turn off the proxy. There is a Acunetics testing app. This application is published by Acunetics. Suppose this application is attacker controlled. So I'm going to copy this, although this lab already give you the exploit server. So let's try here, come back to the repeater and just paste that. So now what we are trying to do here is we put HTTP, and this is our control domain. Fine. So once we send this request, let's see what the response is going to be. Here definitely you are going to get miss because it's been a bit time we didn't send any request. So the request will not come from the cache, but the most important point is this one, especially this source value, right? So send this request and 500 internal server error. Why? Because of this maybe. Send this again, and this time that works, but here we did not find what we feed here. Send it again, same. Okay, x forwarded host, we put the right spelling. X forwarded host, it is actually everything is in the small, not in the uppercase. Let's try first x forwarded host. Let's see. And yes, you can see here. Now this time, this response try to load this tracking.js from this web application which we send. Everything is good. What we can do, send this again and come here, copy URL, go back here and just try to paste that here and send it again. Let's see what happened here. And as you can see here, connecting, see the left hand bottom corner, connecting to testphp.worldweb.com, which is this. That means what we got, we are the user, okay, and we are trying to access this, and this response coming from where? Coming from the cache, and it try to load test this side what we put. So I think the picture is clear. Now you just need to do what? Go to the exploit server, okay, and suppose this exploit server is controlled by you and you are a hacker or a penetration tester, okay. So the first thing what you need to do, where is the path? This is the path, /resources/js/tracking.js. So just copy this path, okay, go to your exploit server and instead of this path put this, okay, and then here, because this is tracking.js, it's already JavaScript file, so you just need to put the, let's say, JavaScript function, like I'm putting here alert, and inside alert I'm saying happy hacking, okay, stored this exploit, and by storing this you just need to take that, okay, or don't need to put everything, just take this, copy and come back here, because it's already going to add this resources/js/tracking. So this time I'm going to just put that exploit server what I controlled and just send this request, and make sure here it's updated and updated. So send it again, so you get a hit, that means it's inside cache. Without wasting time, just copy the URL, go back to your browser, add new browser and paste it, hit enter. We should get alert here, and we get the alert. That means what? That means we feed the malicious response, or we memorize, store the malicious response in the cache, and now as a end user, when I try to get the same request, okay, when I try to get the same response, I get the response from the cache, and that response is malicious and poisoned. So this alert JavaScript executed on my end, means my browser end. So this is the whole picture. I hope you understand. But the lab is still not solved. So what we need to do to solve the lab? Poison the cache with a response that executes alert document.cookie. Fine. So we need to go to the exploit server, and here just paste that, store it. And one more thing I will let you know. This time I'm going to, because now I know that my attack is ready to serve to other users, because this endpoint or this parameter is not for any other user, because users will access slash the main home page. So take this out, and the X forwarded host is already, the exploit server is same. We just change the script. Just send this request again. This time we will get miss. So the response is coming from direct to the server. Now the response is already feeded in the cache. So just go here and try to refresh the page, but this time we are not going to send this. Okay, so this time document dot cookie is executed. Fine. So that's it. If we try one more time, one thing to be considered here, let's refresh it many times. Now you see, this time we did not get the alert, right? See, we are not getting the alert. Why? Because the time is over and the cache is refreshed, and the previous response in the cache is already deleted. So we are getting the genuine response. But once we send this request, we get hit. That means it's now inside the cache. Go back here, and this time we need to wait until the cache is cleared, because the genuine response already inside the cache. So just wait for 30 seconds, and that will be, this was the 27th. Let's send this 25, 30. Okay, and this time is miss. So now this cache, this response is already in the cache. Just hit enter, and this time we should get alert, and we get that. Okay, so that is the thing. I hope you understand. If you like the content, please like, subscribe and share. If you have any query, please put your query in the comment section. I'm going to see you in the next video. Bye.